All right, so to jog your memory for a moment, stoichiometry is just chasing units around the page and getting them all to cancel out. So let's say you've got some arbitrary number of grams of a substance. So here's your grams. Let's just call it the grams of A to keep track of it. To get rid of those grams and turn them into moles, I need to divide by the molar mass. So that's 1 mole has some number of grams of A in it, and that would be a mole of A. And because these two things are on opposite sides of the divider, you'd be left. So right now, if I ran this multiplication sentence, I'd need to just get units of moles of A. Let's say I need moles of B. I could set up a second equation with mole A on the bottom and mole B on the top. Well, that's neat. And here it cancels out again. And I'm just left with whatever my multiplication sentence gives me here as my units of mole B. And I can keep building this until I get to the units I need. Again and again, just canceling across the top or the bottom. It's kind of like you have a factory where, okay, N comes in grams. And, okay, it comes in. And then I've got some machine here that like pick up grams. And when I pick it up, it changes it. And then it puts on the mole factory line. Well, if that needs to go, I need to turn it to grams a different way. I've got another machine that can pick that up and put it on a third track. Does that make sense? Like each thing is like a little factory. Each one of these things does exactly one job to build it up. So each parenthesis here represents like one function. And so as I go through, I'm just really building up a little factory to make the problem work. I'm really just thinking sequentially what happens. If you're stuck on Stoich, or you're one of the people who are like, Mr. Stoich is impossible, I think you'll find it easier as you go along. And certainly with these gas laws, it's not too terrible. So let's take a look at the problem here. So it tells me how many grams of potassium chloride decomposed to potassium chloride and 638 mils of oxygen at 128 C and 752 torr. So to me, the question is asking how many grams of chlorate form. That's where I'm ultimately trying to get. So my N thing needs to be grams KCLO3 on top. And somehow I need to use a gas law to get there. And if you think about it, what we've done so far in Stoich is kind of a three-step process. Okay, we start off with like find moles. And then we do some like molar ratio work, and then we find grams. Well, these second two steps over here, these guys, yeah, they're not going to change. The only thing that's going to change here, because I can't find moles using the molar mass when I'm not given grams. I need some other way to find grams. Or even better here, to find moles, because I can feed the equation moles. So excuse me. If I'm trying to find moles, I have one key equation in gas laws, and that's our friend Puvnert. And he's our friend because he's got a moles already built in. So if I solve for N, that is if I take PV divided by RT, then I can find the number of moles and plug it into the normal molar ratio and get grams back out after another step. It really is only one step different than Stoich you've done 100 times or more. Now, one thing to note is on the test, this is going to be a relatively small part of the grade. It's going to be one question, like half a letter grade. It's not the most important part. But it should also just be free points because you've done Stoich enough times that this should be familiar. So let's just talk through strategy very fast. On this particular problem, it looks like I'm going to solve for N. Then I'm going to do a molar ratio. And then I'm going to find grams. So let's do that step by step. So step one, again, was to find moles. And again, we said that's going to be PV equals NERT, or N equals PUV divided by RT. And so N set up here. So let's see, pressure. So I need to convert 752 torr to an atmosphere. And I look at the table and I say there's 760 torr in 1 atmosphere. So if I take 752 here and I divide it by 1 atmosphere, then I will get the amount of torr in 1 atmosphere. Let me rephrase it. Then I will get the atmospheres present. So we can start off by saying our equation, N equals, let's see, our 752 over 760 And 760 again is just a conversion factor coming from your sheet to figure out how many torr are present in one atmosphere. So since it's 760, 752 is smaller, so we should get a number just smaller than 1 in the high 0.9s. Okay? Now volume. I can't use this 638 up here because it's in milliliters, but I can certainly put it in liters by just moving the decimal point, 0.638. And now I've got the top of this thing set up. Okay, on the bottom, R never changes, 0.0821. And T needs to be that 128 plus the 273 we used to go from centigrade to Kelvin. And if you do all of that correctly and you type it into your calculator, you should get 0.0192 moles. And there we go. Now we have everything we need. I can restate the question. So let me just read you the question from your blue sheet again a little differently. How many grams of potassium chlorate, given a molar mass of 122.5 grams a mole, decomposed to KCl and 0.0192 mole of oxygen? Well, that's a lot easier. We've already done that. That's just normal stoich. So again, once I've solved for moles here, and sometimes you'll start by working normal stoich and using pubnerd at the end. Once I've solved for it, I can go through and pretty much set it up the way I'm used to, like this. So I know from that last slide I have 0.0192 mole oxygen. I think everyone will agree with that. I know that I need to get rid of mole oxygen here. But that's not what I asked about. I asked about grams of KClO3. So I need moles of the potassium KClO3 chlorate up top. And I look at the periodic table and I say, oh look, there's a 2 in front of KClO3 and there's a 3 in front of moles of oxygen. And so what I'm going to get here is 0.0128 mole of KClO3 required, just like normal here. But that's not done yet, because I need to multiply that by the molar mass. So I could multiply now by the 122.55 that I gave you, or I could put it up in here, which is what I prefer, but honestly your choice. And up here this is grams of O2 to moles, or grams, excuse me, KClO3, or getting ahead of myself, to moles KClO3. I can check if my work's set up right by just canceling. Moles cancels moles O2, moles KClO3 cancels moles KClO3. I'm left behind by grams of this. So you take this, you run it through your calculator, and you should get 1.57 grams. And that should be your final answer. That's really all there is to this. Let's kind of recap for just a moment. So your general problem flow is going to do one of two things. You're going to start with normal stoich. And if you start with normal stoich, you're going to end with PV equals nert, like we just did. The other thing you could do is end with normal stoich, which if you end with a normal stoich, that means you're starting with pubnerd. And really, the way to figure this out is just do the reactions. If you get stuck, I'll answer questions on it in class on Friday. It's not meant to be crazy. What I need you to do is just run pubnerd and then do a little bit of stoich, 1 to 2 steps. Or do a little bit of stoich and then run pubnerd. Whatever it needs to do for the problem. So like on number 1 on your sheet, it's almost identical to number 2 in terms of how you do math, except I told you STP. Okay, well STP, remember, is 273 K and 1 atmosphere. Number 3, again, asks you for grams given gas constants. It's really very similar to number 2. As a matter of fact, number 4 is about the same. And if you see there's a pattern in these 4 questions, that's good, because these 4 questions are the kind of question, I will only ask one about it, but the kind of question that will show up on your test for gas stoich. As long as you get this down today, or at least enough to come into class and ask insightful questions, you'll be fine on this. So if you have any questions, I'll be back at school by about 2:45, and I'm happy to help then or by email. and again in class. Again, right now your schedule is a free response test on Tuesday of next week with a review time tomorrow at minimum. So I'll see you on Friday, and I hope you have a wonderful day.